sequences and summation notation. Let's start with sequences. A sequence is a function whose domain is the set of a natural numbers. The terms of the sequence are the function of value a sub 1, a2, 3 to n. We usually write a sub n instead of the function notation a of n. So the terms of the sequence are written as a sub 1, sub 2, sub 3, so on and so forth. The numbers a sub 1 is called the first term and a sub 2 is called the second term. And in general, a sub n is called the nth term. So let's take a look at this first example. Consider the sequence of number 2, 4, 6, and 8. 2, 4, 6, 8, and so forth. So the first number, a sub 1, is the first term, that is 2. So a sub 1 is 2. The second term is 4. The third term is 6. So note that each time we multiply, each time, this is an even number, right? So it is of the form of 2n. So this is of the form of 2n. So the general term is 2n for n being natural number, for n equal natural number. Okay. Let's take a look at the next example. Consider the sequence of number 1/3, 19, 127, 181. So the first term is 1/3, the second term is 19, the third term is 127. So note that a sub 1 equal to 1/3, a sub 2 equal to 19. So 19 equal to 1/3 times 1/3. A sub 3 is equal to 127 equal to 1/3 times 1/3 times 1/3. So this can deduct that when we do the general term of this would be 1 over 3 to the n, for n being natural number. Okay. So let's double check. Well, then a sub 4, that will be 1 over 3 to the 4th. That is 1 over 81. So that check out. Okay. So take a look at this problem. Find the first 5 terms and then the 100th term of the sequences by each formulas. So the first 5 terms, so a sub 1 equal 4 times 1 plus 3. That is 7. Second term, a sub 2, 4 times 2 plus 3. That make 11. A sub 3. So the 100th term, and the next one, a sub 1, that equal to negative 1 to the 1 divided by 2 to the first, that is negative 1/2. A sub 2 equal negative 1 to the second divided by 2 to the second, that make 1/4. A sub 3 equal negative 1 to the third divided by 2 to the third, that make negative 1/8. Note that there is alternating sign here. Start with negative, right? So note that here in this case, if n is even, a sub n is positive. And if n is odd, a sub n is negative. Okay. So a sub 4, 4 is even, so this is 1 over 16. A sub 5, 5 is odd, negative 1 over 32. So the 100 term, a sub 100. But 100 is an even number. So that is negative 1 to the 100 divided by 2 to the 100. That is 1 over 2 to the 100. And let's now calculate that out. Let's say we want to use graphing calculator to calculate the following. Find the first 10 term of the sequence, then graph the 10 term of the sequence. If we look, so when we look at a equal to 12 over n, in order to graph this, the first thing we need to do is to make sure that your calculator is in sequence mode. So start with mode. And make sure that your calculator is in sequence. So just move it to sequence, enter, and then quit. Now, start the plot. Y equal 12 divided by n. Now we want to see the graph. So this is the graph of the first 10 term of this. This is the graph of the sequence. So let's use this calculator to find the first 10 terms of the sequence. So let's take a look at the table of value. So here is the list of the term that is in the sequence. So here you can find the list of the first 10 terms. The list of first 10 terms. That is 12, 6, 4, 3, 2.4, 2, so on and so forth. Okay. So here you can fill out the list of the first 10 terms yourself, and you can also graph this. Note that because this is the plot of a sequence, we don't have the term to be n cannot be negative because n is supposed to be a natural number. So natural numbers start at 1. Okay. In the next problem, where we have a sub n equal 4 minus 2 times negative 1 to the n. So let's take a look at what that plot would look like. So 4 minus 2 times negative 1 to the exponent n. So because we have a negative 1 here, I'm expecting that we have alternating in the sign. So let's take a look at the graph. And here we have alternating term. Okay. So take a look at the table. And here we get an alternating. So that is the first 10 term and the graph of the series. Excuse me, sequence. Okay. So the next thing we want to do, let's say we are given we're given a list of number in the sequence, and we want to come up with the nth term of the sequence. Okay. So let's take a look at the relationship of each of this number. So we start with 1. So a sub 1 equal 1. A sub 2 equal to 3 over 4. A sub 3 equal to 5 over 9. A sub 4 equal to 7 over 16. So note that the numerator, so odd numerator, okay, and the denominator seems to be the square of the term. So the square of the number. Okay. So then to write this is what if we want the first one to be 1, so we're looking at 2n minus 1 divided by n squared. So let's check this to make sure that we get it right. So a sub 1 equal 2 times 1 minus 1 divided by 1 squared. That 2 minus 1 divided by 1. Let's make 1. A sub 2 equal 2 times 2 minus 1 divided by 2 squared. That is 4 minus 1 divided by 4. That is 3 over 4. So it's simple to check out. So this is our sequence. Take a look at the next one. Well, a sub 1 equal 3. A sub 2 equal negative 0.3. So that is negative 3 over 10. A sub 3 equal to 0.03. So that is 3 over 100. A sub 4 equal negative 0.003. That is negative 3 over 1000. So first of all, we have an alternating sign. So a sub n, we have an alternating sign. So we have a negative 1 to the exponent of something. Okay. And look at here. So here we have 10, 100, 1000. So note that 100 is 10 to the second, 1000 is 3 to the third. So this is the exponent of 1 less than the number of term. So look like this sequence is come out to be 3 times negative 1 to n minus 1 divided by 10 to the exponent n minus 1. So let's double check. So a sub 1 equals 3 times negative 1 to 1 minus 1 divided by 10 to the 1 minus 1. That is 3 times negative 1 to the 0. 10 to the 0, so that makes 3. A2 equals 3 times negative 1 to the 2 minus 1 divided by 10 to the 2 minus 1. That makes 3 times negative 1 to the first divided by 10 to the first. That is negative 3 over 10, and that is negative 0.3. So look like it check out. This is our sequence. Now it seems easy when I do it because I've been doing this for a very long time. So don't get discouraged when you don't come up with this answer in the first time. It takes some practice. So practice makes perfect. Just pay attention to little detail of whether we have an alternating sign, whether we have an exponent somewhere that you can think of. So just give it a try.